All right, let's talk about something weird. That's const. Believe it or not, this might come as a shock for you, but my native language isn't English. So when I do this lecture in Swedish, it's a lot more, it's somewhat fun because const, the word const, is in Swedish konstig. Konstig is weird, but weird and const. So, okay. Anyway, let's begin with const. Const is what we're going to talk about today. And we're going to start from a practical, a problem we often encounter. Let's have a look at this. We have a class player, and the player is we are good object-oriented programmers, so we're using encapsulation, so we have private variables, and we have a getter. This is a getter, so it's only getting it, right? Then we create a player, and we also have overloaded the stream insertion operator. So what we're doing is we are trying to print the player, and what we want to do is not print, send it to the stream, of course, and we want to do this. Why isn't this working? I mean, all we're doing... Actually, let's have a look at what it's saying, first of all. Okay, the object has type qualifiers that are not compatible with the member function. Oh God. But I mean, there are some hints for us. Let's have a look at this. Okay, so the object type is const player. All right. So and I mean, it's so far we have kind of understood, I hope, that const is it is a good thing to use const whenever we can, and I will talk about what it really means, and it will become clearer when we use const and not. But the problem is, what is the problem? I have no idea. It's not that easy. I will solve it, and then I will explain it from the beginning, and then we will go back to this example. It will be much more clearer. So actually, what we are saying is this function is not. We're not saying. The compiler is saying this function is not const. And what does it mean for a function to be const? But let's just fix it. So if we add the keyword, so I'm not saying we're kind of, you will see soon there will be const in multiple places, and sooner or later you just, okay, so I throw in a const and see what happens. But I will try to make it so it makes sense. Anyway, now the function is marked as const, and the thing is, since we are sending in a const, and I do know I haven't explained what const is, I will soon, but since we are saying that this player object is a const, then we can only call functions here that are marked as const. So that's the thing. Now we know at least the syntactic way of solving it. Okay, so we add a const, but what does it mean? Let's start actually by just creating a variable. this is a variable, right? You do know what a variable is. The thing about the variable is that it could be modified. I mean, you can hear it from the name, variable. Variable. It's variadic, or what you say. So it's possible to change it. That's a variable, of course. Okay, so actually, let's just do this. Okay, let's modify it so it's const, and I hope it will soon. The red squigglies should. Come on. Why is it so slow? It should. Do I have to compile it for the squigglies to? I mean, VS Code is it's so slow sometimes. Actually, I'm not sure. I'm not even sure, but it should. Okay, so it's complaining on other things maybe. I mean, and this is our daily life as a C++ programmer. No name, what is this? And we have to, okay, cannot convert player to const unsigned car. No, what's going on? Oh, sorry. Oh, my bad. Now, okay. Okay, so it was a that's me in a nutshell, you know, clumsy fingers. Anyway, let's now the red squiggly is there. Okay, so a const. Of course, we can't modify a const, and I mean this is a rather weird const. We should probably, I mean, maybe not but the const should be usually something that's not modified. So that's a bad constant. But I mean, it could be const int default VAT%, which is 25. And I mean, this shouldn't change ever in the program. So I mean, this makes sense. It makes sense for us to, okay, it's not possible later in the program for some stupid programmer to modify the variable. Because it's not a variable, it's a constant. It's a constant variable. Anyway, but I mean, as you can see, I mean, in some way, our program would work. Let's go back to this. I mean, as you can see, our program would work the same. We could, of course, use that that variable whenever we want. Oh, sorry. Let's just. I have no idea what I'm doing, but anyway, doesn't make sense. But anyway, I mean, we could. Sorry, I forgot to start as well. Anyway, okay. I mean, this will work fine, just as fine as this will work. So const is actually, it doesn't have so much meaning, as in I mean, when you make a promise, you don't have to oblige to it. This is kind of the same. So it's I will show you. We will soon see how we could, in a sense, actually modify this variable, this const, even though it won't work. I will show you. Anyway, we could, as I said, I mean, const is more of a semantic, it has a semantic meaning. It also has a meaning. I mean, the compiler won't allow you to, But for the result of the program, it will be the same. The program will be the same whether we use const or not. So it's kind of a help for the programmer more than all that important for the end result. In the end, it is important for the end result, but because it helps us not make mistakes. But that's the thing. All right, we could, as I said, of course, we could also have pointers, right? We could have a pointer to an int, and we could set that pointer to, for example, a new int. And we could, of course, by dereferencing the pointer, we could set its value. We could also do, and have a look at this. This is, we could set the pointer to, instead of pointing to this one, we can set it to point to the address of this variable. But it's complaining. Why is it complaining? It's complaining because this is an int pointer, and that's a different data type than this. This is not an int. This is a const int. So it's another. So we need to. But I mean, it's so easy. We could just typecast it. So we just typecast it. As you can see, this the data type of this expression. That's a pointer to a const int. The address to a const int. But we could always, it wouldn't be C++ if we couldn't, find your way around it. Actually, and now my point is, could we do this? Let's try it, and you will see. I will just set the breakpoint, I think. Okay, so let's do this. So now the value where p is an int pointer, it's pointing to an address, and in that address the value 12 is stored. Let's now put p to this address instead. And now you can see p has a different value, and if we dereference p, we have a look at it, it says, oh, it's 25. Actually, I should have done it the other way first. But when we try to add it, actually it worked. Yeah, okay. That's right. I was actually expecting another thing to happen, but let's not talk about it now. That has to do with how, the different variables, when you start up your program, global variables and constants are initialized in a certain order. Let's not dive into that. So this is working. It's even better. Now you can see that the const thing is almost always something you can avoid. Okay, so it's const, but I have my way around it. Anyway, so the thing is about the thing about consts is that it is kind of a help for us programmers. It's meant to be, but often it's the opposite. So sometimes I feel like, okay, it would be better not to have const when we get errors like the one we had. Let's continue. So, even pointers can be consts. Oh shit, what is it talking about? Okay, so, and I mean, you have probably seen it. When you look at the standard library or any library, you see things like, okay, so it's sprinkled with const. So, what will this mean? What will this mean? How should we interpret this? Okay, so what it's saying is that, as you can see, it is possible for when we type const on the left side. The thing is, I will soon put const on the right side of the asterisk. Anyway, and soon we will have them everywhere on both sides. Anyway, what does this mean? So the interpretation of this is, okay, so we can still modify the pointer. Okay, so the pointer by itself is not const, but the thing that the pointer points to is const. This is what it means when we type const to the left of the asterisk. I hope it's called asterisk in English. So as you can see, this is fine. It's fine to take a const int pointer and point it somewhere else. So here's the thing. I mean, the pointer is always two things. I mean, there is always a stack allocated area. This is stack allocated, and it contains an address, and that address goes to the allocation, a memory address on the heap. So a pointer has two parts. The pointer itself, which is, I mean, that's it doesn't have to be, but almost always it's stack allocated, and it contains an address. And the thing is, the pointer kind of also have that meaning that if we dereference like this, if we dereference it, it will it will point to something. So the value it points to. So there are two sides, if you say so, of a pointer. Therefore, we also have two meanings when using const together with a pointer. Oh my god. Okay, have a look at this. So, okay, so remember, when const, I will try to write const to, let's const to the left. Const to the left. That means that you can't modify the thing that the pointer points to. Okay. Now, let's instead move the const to say that, okay, so this is an int pointer const p. Woo! All right. And what does this mean? This means that it means the opposite. It means the opposite. So whenever you see the const, when you see to the left a const pointer, when you see const used to the right, then it means const to the right. It means you can't modify the pointer address, so you can't make the pointer point somewhere else. All right. So as you can see, we have two meanings when we have const either to the left. Actually, it could be here as well, as long as it's actually the same. I mean, this line is the same as this line. Of course, there couldn't be just one way of doing things. So when you Google and you end up with Stack Overflow, there will be, okay, you always learn new things. I didn't know you could put const there and so on. Okay, yeah. So we talked about. Sorry, we talked about to the right. Let's move it to the right. Okay, like this. Sorry. Okay. So now the const is you can't modify the pointer address to point to something else. All right. And of course, as you can see, there are two different meanings of const in conjunction with a pointer, an asterisk or a star. And of course, you can combine them. So let's do the last thing. It is possible to, as you can see, now we have the red squigglies. We can't. I mean, this is a real const integer, so it can never be modified in any way. And I mean, typically we would have a value, I think. Otherwise, it would be weird. A starting value. But I mean, now the value is we have a pointer. And you can't modify what it points to, and you can't modify the address of the pointer. Okay, so this is, I mean, maybe this is the important thing. The important thing. This is not all that important. I can tell you that. I mean, very often it's possible to, I mean, when you start C++ programming, you don't dive into constness the first weeks or so, or the first 10 years. I mean, it's really, but I mean, there are two ways of how to program C++. I've talked about it before. So first you have, okay, the naive kind of, I don't mean that in a bad way. On the contrary, simple is always best. But I mean, then it is the hardcore C++ way, when you really focus on things like const, and I mean, this is not intuitive for anyone. if you're not a member of the C++ standard commit, no, I'm joking. It's not that hard, but it's not easy either. I give you that. Anyway, that was const, and const together with pointers. We also can use const together with references. And what does that mean? Let's go back to this one then. Okay, what does it mean for a function to be const? I mean, for a function of a class, what does it mean for a function of a class to be const? It means that when I say, hey, I'm const, get name says, I'm const, it means that I swear and I promise that I do not modify the internal state of the object. So why should that matter? The same reason why this matter. Why does const matter? Because it has a semantic meaning. It also means stupid programmers aren't able to modify the value. I mean, no, sorry, they don't have to be stupid. They could even do it by mistake, of course. And we want to avoid when there is, I mean, the semantic value of a constant. It is a value, and it's the same value can be applied for objects. So we can have certain functions which has a signature saying, when you call this function, you can rest assured that nothing in the state will be changed, which is kind of the same semantic as here. So the semantic is just, okay, this function, this variable or a constant will not change. So it's the same when we call this function for foppa. When we call player.getName, we can be assured that nothing about foppa has changed during this call. That is what const mean. I will show you. I will prove it to you. And I fully understand. You might not see the value of it. I mean, the value of const when used for ints and so on. It's more, yeah, understandable. The value of const for an object might not be that, but there are multiple reasons why we should do it. I will not go into all of them, but I mean there could also be optimization. There could be, I mean, we are avoiding mistakes and so on. There might be getters that are being called multiple times and so on. So it would not be good to add some changes to the anyway. Let me show you. Let me prove I'm right. So in this, so when we call the getName, I'm gonna say that jersey is added. Yeah, weird. I know. So each time we call the getName, we try to increment the jersey number. And I mean, this, as you can see, this is not possible. Why isn't it possible? And now again, if you're not feeling welcome already, welcome to C++. I mean, does this help you at all? Expression must be a modifiable L value. Because, have a look at this. If I remove const, maybe I should, okay. So now, as you can see, it's possible to modify the value inside our object. So when a function is not marked as const, we are allowed to modify the state of the object. And as you can see, this is, I mean, it's enforced by the compiler, and it's a good thing. Just like it's enforced down here, if we try to modify a const, it will say it's enforced by the compiler. It's not possible. And actually you can see it says it is the same error message. Maybe I will get into L values and R values, because not because I want to, but because it's so many error messages where it just spits out okay, L value, R value, what is it? I might talk about it further on. Okay, so when it's const, you can't modify it. That's the whole the whole meaning of it. And once again, I fully understand if you don't. Okay, I don't feel like using it, but actually you do need to use it in some when you, for example, need to, you need to override an operator or some kind which must take a const reference or something, because a signature says so, or something. So then, I mean, the reason is, why doesn't this work? Let's go back to this now that we know what is a const. A const is a promise. I won't modify anything inside that code, that object, sorry. And as you can see, this function, this operator, takes a const reference to this player. And since this is const, this function by itself can't modify anything inside the player. Why can't it? Because it's const. We are getting something, and we are it's const, and therefore we shouldn't be able to modify anything. If we do this, then we are able, have a look at this, now we are able to call non-const functions. So you can see const is, if we say this thing is const, then everything, all the in the calling chain will need to be const. And the only way for a compiler to know, okay, the compiler sees this, this is const, okay, nothing inside here in this function could ever modify, should not be able to modify this object. So the compiler, how can the compiler be sure that this object is not modified? The only way for the compiler to ensure that this object has not been modified when we leave the function is by only calling const functions, because the compiler no, okay, it's so slow today. The compiler need to be sure that this has not changed when we leave the function, because the compiler, we have promised that, and the only way to ensure that is to not call any non-const function. Okay, so let's see. I know there was one more thing I wanted to talk about. Maybe there wasn't. Okay, so actually we will talk more about const when we talk about references and so on. But basically, it could be so many weird things going on. Let's say, we could, for example, if for some reason we should get your say pointer for some reason, I have no idea why, but let's say we should return the address to yours for, I have no idea, and you could actually then have you could have const star int const, I think explicit type is missing. Okay, so we need to just, as you can see, it's just I will force C++ to do whatever I want. Okay, so I didn't sorry, no, like this, then const int, sorry. Anyway, so as you can see, this is so weird. I mean, you just almost start crying if you ever... But as you can see, it's possible. So what we're doing here, we have a const function, and the const function promises to not modify anything inside the object. And then we are returning a pointer to an int, but we're saying you can't modify either what it's pointing to or the pointer itself. It's, I mean, const, that's just weird. I don't want to look at it, seriously. Now I remember what I wanted to talk about. I wanted to talk about, I mean, yeah, there are rules. Have a look at this. I mean, okay, so, this was not possible. Okay. Could there ever be a reason for us to kind of not follow the constness in a member function? Yeah, of course. There are always reasons to break a promise, right? I mean, there could be, yeah. I have a great example. We could have maybe some debugging or auditing. So we could have a vector, of some class. I won't create the class. I just want to show you kind of a real example of the audit log. So in this case, for, you know, in some systems you have to have auditing. So who has accessed that function or something. So it might be implemented like this or maybe not. That doesn't matter. But let's say we have implemented it like this. So what we would like to do here is each time a function is called, we need to add some log information to this. It was a bad example. I mean, we could probably implement this better by just calling to another function or another object. Anyway. But the thing is this: sometimes there are exceptions, and let's just create int. Let's say this is number of calls. I don't know. So each time, actually, yeah, I have forgot to tell you this. So it's also possible to initialize values like this, even for member variables or attributes or whatever we should call them. So you don't always need to, you know, calls like this. So it's possible to. It's getting more and more modern, C++ as well. So this is possible. This is fine. But I mean, let's say each time we this is not possible then. It isn't, and it shouldn't be, because we are modifying the internal state. But we could kind of, but that's not the real internal state of this object. That's just a debugging thing or something, an auditing log or something. So please, never mind. I still need this to be const, but I also need to modify a variable. So there is a way out. So we have this I don't know if I should say new, but I think it's pretty new. There is a new keyword, mutable, like this. Yeah, there. You know, this is so seldom I use mutable, but there are cases when they come in handy. I mean, when you own all your code, it's possible when you create your own code from start to beginning. It's really possible to never care about const and so on. But when you are using other people's code or other organizations' code or third-party code, you are kind of stuck in their constness implementations and rules, and you could get into this type of, okay, so this has to be const because it's called by another const method from somewhere else, but I still need to modify something. So let's but I mean it's so the mutable, actually, I mean, I need to I should just Google it, mutable C++. So I'm really so I'm really okay. It didn't say much at all. Okay, but I think let's there are no squigglies, so let's try it. If it works, then then it's correct. Then you know, you're always like, okay, where should mutable be? Yeah, it did work. Okay, so should it be first? Should it be last? Where should I place it? But if there are no red squigglies and the program is running, so I don't have to look it up. So it's like this. Okay, so mutable is useful in those cases, although it's kind of an indication that maybe you are thinking about this problem in a problematic, I wouldn't say in a wrong way, but in a problematic way. So maybe you should reconsider something, but sometimes you just can't. So mutable is usable, no doubt about it. Okay, so let's stop the weird things about const, and the final words are. I hope you have kind of gotten an understanding of where should I place const, what does it mean. I mean, it's obvious when we talk about const int, const float, whatever, but not so obvious when we talk about const functions, methods for in classes and so on. All right, let's say goodbye for this time.